Hello friends, welcome back to the bench. Our patient today is a Chevy Cruze 2011 to 2016 ECM for repair assessment. Now, it's pretty heavy. This is what it looks like. Aluminum everywhere. The way we open it, well, actually, let me show it to you on this camera. So we have 4 screws, and it is of course glued in with, I assume, silicone. So there's a little bit of force that you need to apply, and it will result in some bending. But that's not an issue. That's easy to fix, easy to make straight again. Which reveals this side of the ECM. Now, to gain access to the other side, we need to desolder this connector, this connector, this connector, this big pin over here, and this big pin over here. That will dislodge the board. Now, if you're wondering how I got all this desoldered, I assure you I did not use the regular hand desoldering pump. This would have been crazy. I mean, I probably would have done it, but the quality would not be as you can see over here. I'm working on the video to show you guys how to perform these, but still it took a while. It definitely took a while, even with good hardware. But what do we have on this side? Well, turns out that the majority of components, and actually all the components on this side of the board, are the output stage components. Hence, the components that are potential to have the potential to break. Majority are the MOSFETs. There's plenty of MOSFETs. So we have 2 over here with something disconnected from my computer. I don't know what, but that's fine. So we have 2 MOSFETs over here, right, with pretty big resistors on, not on the gates. This is the gate here. So this is probably drain. It goes to one of the pins, and this is our source. Most likely, it could be the other way around. This could be drain, this could be source. So we're driving something on the output with this one. This one, probably the same, but it goes on the other layer of the board. And we have a few more over here, and a whole array of MOSFETs. Each one controlled with 10K resistor. So suppose there's something doesn't work, perhaps a injector or a coil, or some kind of fan like we did in that 2005 Subaru. Then what we do, we just inject a voltage around 5 volts and see what's getting hot. And what's gonna get hot is gonna be on this side of the board. So you don't need to desolder these to solve these problems, right? The same way, likewise, we have another row of MOSFETs over here. Some of them appear to be dual, some single. These all appear to be dual. We have 2 driving pins, right, on each one of these, and 2, well, most likely these are dual. I didn't actually check, but we have nice marking on these, so we could check. This is S09007, so that is a specialty chip, but most likely if you replace the S with M, you will find it, most likely you will find it available as freely available chip, but not with S. I mean, with S you can get them, but only from China. No one in US sells these, so it's a bit long waiting period. I am still waiting for. About a month ago, I ordered, like 3 weeks at least, the chips for Subaru, also S chips, and I'm still waiting for them. It takes a while. Not sure what this is, but we have pretty much all the connections to it are logical connections. So this might be some kind of memory, maybe. I doubt that, but could be. Few more MOSFETs. So this is also our output stage, most likely. We have 2 pins over here connected together, and 2 over here. So this might be an injector driver, or usually when we have the chips like that, they're usually either the injector driver, the coil driver, or the CAN bus driver, I mean output stage driver. So that's most likely one of these. We have plenty of resistors here. Another chip, this one with P, but hard to say which one's the model. But the same deal. We have few control pins. We have plenty of power pins, like here, and we're going into the transistor. Interesting. So it looks like this chip has an output stage in the form of this transistor. We have few caps that are prone to shorting, but since the ECM is not like Subaru's in plastic enclosure, although I've never seen any issues on Subarus because of the plastic enclosure, they're still pretty well mounted. But this one has aluminum cover, so I wouldn't expect any caps to get shorted. We have some diodes over here, so this is probably where we receive our voltage input, right? Our power rail. Sorry, I had a bug on my bench. More transistors more resistors, capacitors. This was unconnected, probably for some other version, or maybe some kind of debug port or programming port, something like that. Plenty of discrete components over here, and that's pretty much it. That's all the access that we have from this side. So now let's dig the board out. So these are our pins on the other side, right? And here, as you can see, no melting, right? No pins missing, no nothing. This was a successful removal. It usually doesn't go that well. Let's grab some focus and let's flip the board. So this side is pretty interesting. So we are using we would have to decode this. You can decode the frequency from this number. I would guess 8, maybe 10 megahertz. Our MCU in a very interesting package. It's mounted on the PCB, and then PCB is soldered on. So relatively modern. Another chip over here. This could be the same deal, ECM and TCM on one board. Some chip over here that looks, could be some kind of memory. Now, and this is where we connect to, this is how we drain the the temperature from the MOSFETs that are on, well, actually not MOSFETs, this chip. So this chip is heating up. That's why it has thermal conductive paste over here, which touches the big aluminum piece. The recoils. So this is where we produce our rails. From 12 volts to, I'm guessing, 3.3, 5, maybe 1.8, 3.35. All coils are the same. Look at this here. Interesting. Very interesting. That's how wires are soldered onto the leads over here. Interesting. These are probably optocouplers, I would guess. Could be, but that's weird to have optocouplers here. I wonder. More resistors, and so looks like while our MOSFETs are on the other side, so this is a row of MOSFETs on the other side, here and here, but the gate resistors are on this side. So if the gate resistor is faulty, which is very unlikely, very unusual, but it happens, then we do need to remove the board to replace the resistor. So that would make it less repairable, because it's really not worth all this hassle to remove the board. It's better to just acquire a replacement ECM and program it. Speaking of programming, this is a second row of MOSFETs and also some resistors on this side. But speaking of programming, the reason I wanted to remove the board and see it on the other side is because I was looking for an EEPROM. And I wanted to read it and see what's inside it. But I do not see any EEPROM that would be compatible with what I can read or write. So, most likely, either our MCU holds that information and it just uses flash. Perhaps one of these. Perhaps here. This could be larger memory. It kind of looks like memory chip, but I don't know. We don't know. There are no markings on the board and no outline either. So replacing this chip would be a hassle. This one as well, even more so, because this is a sandwich. If you overheat it, then the cover, the cap might fall off. Not great. So this could be maybe some memory, but most likely the memory is either here or here. So it's not easy. Basically, if this one is not communicating over CAN, then most likely you won't be able to read it. Probably everything that you can do has to be done through the CAN interface. We have poorly soldered capacitor over here. Interesting. And these two are also not looking great. And the oscillator also is a little shifted. So some of the components over here were resoldered or not resoldered after it came from the machine. Some of them were either not soldered on or moved or something, so manual adjustments had to be made. This is actually, look how close these are. These are logic traces, so it's not like we're pushing a lot of current or voltage over here, but still, these are really close. Let's look at it under the big guy. I lost it. Hang on, I need to find it here. Okay. Yeah, now I see it. Okay. There. Well, too much zoom, but there you go. Yeah, it'll still work, right? But it would bother me if I was doing a QA on this board. This would bother me. I would probably opt for correcting this. No big deal though. And this is pretty much it. That's all we have on this board. As far as the number of components, not many. As far as the repairability, well, the fact that the majority of output stages are on this side, it makes it pretty repairable. No markings on the board, a little less so. You have to remember the orientation of the chips. But other than that, it looks like it's relatively repairable device. Now, perhaps in the next video, I will show you how I desoldered this board and how much time did it take. Not that much, I would say maybe an hour. So this is really good timing for removing this many pins. Not very profitable, but you know, if you like doing this, you know, if you have a proper equipment, it's pleasure. Alrighty, this is Chevy Cruze 2011-2016. Not too repairable, but not too bad. Thank you guys very much for watching. I shall see you in the next one.